All right, let's jump right in. We're going to look at a building technology that is kind of quietly just completely taking over one of the most demanding construction markets on the entire planet. And it all starts with a pretty simple question.
Now you might think, well, that's easy. Just add a ton of insulation, right? But in Norway, it's not that simple. See, the government there has set the performance bar so incredibly high that it basically forced the whole industry to get creative and innovate. And this is the number that changed everything. 0.18. That is the absolute legal limit for heat loss through any new exterior wall in Norway. It's a non-negotiable. And to hit a number that low, builders realized they couldn't just keep doing what they'd always done. They had to find a totally new way to build. And this one single rule created this massive challenge, but also a huge opportunity.
So you have to understand, this wasn't just about keeping people cozy in their homes. This was actually part of a much bigger national strategy.
The Norwegian government is all in on timber. They're actively pushing wood construction to hit their green economy goals. I mean, it makes sense, right? Wood traps carbon, it's a renewable resource, and it takes way less energy to produce than concrete or steel. This policy created the absolute perfect environment for a new wood-based building solution to just completely thrive.
And that brings us to the hero of our story, the IBeamPanel system. Now, it looks pretty simple, but honestly, its design is nothing short of genius. So what exactly is an I-beam? Well, it's an engineered composite. You've got these solid wood flanges at the top and bottom, which give it its strength, and they're connected by a really thin web of something like particle board. The key here is that the design is super resource efficient. It uses way less of that high-grade timber, but keeps all the structural integrity. But its real magic trick, that's all about how it handles heat.
Okay, so this slide really gets to the core of why the I-beam is such a game changer. It solves a huge problem called thermal bridging. Think of a solid piece of wood in a wall like a metal spoon you leave in a hot cup of coffee. The heat just travels right up it. It's an easy escape route. But the I-beam's super thin web, it breaks that path. It acts like a roadblock for heat, creating this deep, uninterrupted cavity that you can just pack with insulation. And that makes it the absolute perfect tool for hitting that crazy low 0.18 number.
So, with this massive thermal advantage, you can see why I-beams aren't just another option on the table. They are flat out dominating a very specific and, let me tell you, very lucrative part of the construction market.
Now, you've probably heard a lot about mass timber, or CLT, and it's amazing stuff, especially for skyscrapers. But for the real sweet spot of the residential market, we're talking buildings between 2 and 8 stories high. I-beams just have this clear, undeniable edge. Their potential for insulation is just built into their DNA because the whole structure is designed from the ground up to create that perfect pocket for insulation.
And when you look at the data side by side, it's even clearer. The IBeamPanel system just checks all the boxes for this market. Thermal efficiency? Excellent. Using materials efficiently? You bet. But look at that column for construction speed. Very fast. Why? Because these I-beams are built into large, prefabricated panels in a factory. And in a country with super high labor costs like Norway, speed is money. A lot of money.
Get this, just 2 days. That is how fast the entire frame of a building can go up on site. The panels, all ready to go. They arrive on a truck, a crane lifts them into place, and boom, you're basically done. In a high-cost labor market, that kind of speed is an unbelievable economic advantage.
And the quality is just staggering. Because every single one of these components is cut by a computer-controlled machine in a factory, the precision is down to 0.2 millimeters. That's tiny, and it guarantees a super tight, perfectly sealed building, which, you guessed it, is another one of those non-negotiable rules in the Norwegian building code.
But you know, this whole thing is about so much more than just a cleverly designed beam. It really represents a fundamental shift in how we build things, moving construction out of a muddy, chaotic job site and into a clean, digital, factory-controlled environment.
So this is what that modern workflow looks like. It all starts with a detailed digital blueprint, something called 5D BIM, which maps out not just the building, but also the costs and the schedule. That digital model then sends exact instructions to the machines in the factory. The panels get built, shipped, and then assembled on-site in record time. And that last step, material tracking, is so important. It means that decades from now, every single piece of that building can be identified and then reused or recycled. We're talking a true circular economy, not just another pile in a landfill.
And if you're thinking this is just some niche, futuristic trend, think again. The Scandinavian market is already all in on factory-built housing. I mean, modular homes alone already make up 42% of the market.
That just shows you how accepted and widespread these modern methods have become. And panelized systems, the ones powered by I-beams, are a massive part of this whole movement.
The momentum here is just undeniable. The market is expected to grow by as much as 7.4% every single year through 2030. This is a multi-billion-dollar shift, and it's all being driven by technologies like the I-beam that solve these really fundamental problems of efficiency, quality, and cost.
So the key takeaway, the thing to really remember, is this. In a market with some of the absolute toughest energy codes on Earth, the I-beam panel system isn't just a clever alternative anymore. It's become the standard. It's simply the most effective, most efficient way to build the kind of high-performance houses the future demands.
Which of course leaves us with one last, really big question. As the rest of the world starts to get serious about energy costs and climate goals, are we all heading toward a future where building codes this strict are just normal? And if that's the case, is this factory-built, precision-engineered way of building what we'll all soon just consider standard practice?